All right, today, section 3.4, everybody's favorite topic, word problems. We're going to be looking at three different kinds of problems, value, interest, and mixture. Number one. Oh, by the way, this sheet, I've posted this sheet online for you to download if you want, so you can follow along, and you'll be doing some of the problems on this sheet for homework, so it might be a good idea for you to print it off. So it's right up there in the same folder as where you found this video. So it'll be called section 3.4 worksheet or something along those lines. Okay. On a special day, tickets for a minor league baseball game cost $5 for adults and $1 for students. The attendance that day was 1,281 and $3,425 was collected. Find the number of each type of ticket sold. All right. Well, the hardest part of any word problem is reading through the material, trying to figure out what they're asking, and once you know that, trying to get your equation set up. Usually, what you want to find is given in the very last sentence. Find the number of each type of tickets sold. So we have two different types of tickets. We have adult tickets, which sell for $5, and student tickets, which sell for $1. So the two things we're trying to find, I'm going to let A equal number of adult tickets and S equal number of student tickets. And it's important to write that down like I did so that people know, people who are reading the problem, in particular me when I'm grading your exam, know what your variables stand for, what your variables represent. Alright, now they give us two types of information here. The two types of information they give us, I should say this, we have two variables. Anytime you have two variables, you need to come up with two equations. If we had three variables, we would need to come up with three equations. Alright, so what I was about to say is they give us two different types of information. And from those two types of information, that's where we're going to get our two equations. One type of information is they tell us the attendance, right there. And the other information they give us has to do with money. Okay, so here are our two equations. The attendance that day was 1281. So that means the number of adults plus the number of students, that's everybody who is there. So the number of adults plus the number of students has to be 1281. Okay? And then money. We collected $3,425. $5 for adult tickets. So that means for every adult, I collected $5. So there's how much money I collected from the adults. And you might remember back to our unit conversion section, you might be checking your units here. Remember, 5 is in dollars, and this is number of adults. So if I take the number of adults at $5 each and multiply by $5, I get a money unit. Alright, plus, this is how many students were there, and I collected $1 for every student. So there's how much money I earned on the student tickets, and altogether I earned $3,425. So there's my two equations with my two variables. And what we have to do now is we have to solve. And we have multiple ways to solve. We could solve by graphing. Probably not the best way to do it, but using our calculator we could make it work. We could solve by substitution, or we could solve by elimination. In this problem, I think either of the methods work, substitution or elimination. I don't really think there's one that's easier than the other. I think I'm going to go ahead and use substitution. So I'm going to take this equation right here, and I'm going to write S equals 1281 minus A. Very, very easy to get S all by itself. Also very, very easy to get A all by itself in that equation. Take that, plug it in right there. So I have 5A plus 1281 minus A equals 3425. Combine my A's, 5A minus A is 4A, plus 1281 equals 3425. Subtract 1281. For A is, grabbing my calculator, 3425 minus 1281, I get 2144. Divided by the 4. And A is, now it better come out to be a nice number, because A is number of adults. If I get a decimal or a fraction here, I'm pretty sure I made a mistake. The good news is, I didn't. I got A as 536. So there were 536 adult tickets. I would now take that, plug it in right there, and the number of student tickets is 1281 minus 536, 745. Okay, so there's my answer. All right, well, you get to do number 2. Number 2 is almost exactly the same, slightly different numbers. So we've got a different number of tickets, slightly different prices for adults and students. Write it down, mimic what I did, see how it goes. Alright, so number 1 that we just did, that was a value problem. And number 2 that you just did all by yourself, that was also a value problem. Number 3 is a mixture problem. Number 3 says, a chemist needs to mix an 18% acid solution with a 45% acid solution to obtain 12 liters of a 36% acid solution. How many liters of each of the acid solutions must be used? Alright, so again, my very last sentence tells me what I'm looking for. How many liters of each? So I'm going to let X equal amount of 18% solution, and Y be the amount of 45% solution. So there's the 2 things I'm looking for. Now, these problems, what I like to do is I like to think of a little chemistry set here. So, I have a beaker that has 18% solution in it. And I'm taking that and I'm dumping it into another beaker. The other beaker has a 45% acid solution. And when I mix them together, I get an answer. And my answer has to be a 36% acid solution when I get all done. Alright, so that helps me to visualize it, to think of what a chemist actually does. Alright, so how much of the 18% solution do I have? I don't know. I called it X. So I put an X right inside there. So that's how much is in that one. Same deal with the 45% solution. I don't know how much is in there. I called it Y. But I do know that when I get all done, I need to have 12 liters of this 36% solution. So that's got to be a 12. Alright, once again, here come my 2 equations. I have 2 variables. I need 2 equations. The first equation is, I'm starting with some liters here. I don't know how many, but I know I have X amount of liters. Let's say, for example, X was 8. If I have 8 liters here, and I'm going to have 12 liters altogether at the end, then Y would have to be 4. 8 plus 4 would have to be 12. I don't know that they're 8 and 4. Maybe they are. I hope not. I didn't work this problem out in advance. But I would have to have X plus Y equals 12. The amount of solution here plus the amount of solution there has to equal the total amount of solution I have at the end. And then the other equation has to deal with the acids. So this is, I have some amount of solution and 18% of it is acid. So if I take 0.18 and multiply it by X, that would tell me how much acid is actually in that first beaker. The rest of what's in there is some solute, probably water. But this is amount of acid in the first beaker. Similarly, that would be amount of acid in the second beaker. And then when I get done, when I get done, this is how much acid I have. So this would be 0.36 times 12. All right? So if you draw this picture, there's how you're going to get your two equations. You're going to go straight across. That's going to give you one equation. And then you're going to multiply, 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 and that gives you your second equation. Once again, this one can be solved quite well using either substitution or elimination. Again, I don't really have a preference, but I think I'll just do this. Y equals 12 minus x. Very, very easy to get y by itself. And plug that in. 0.18x plus 0.45 times 12 minus x equals, I'm going to grab my calculator, 0.36 times 12 is 4.32. We're going to have a lot of decimals in this problem, but that's not really a big deal because we're going to use our calculator to handle all those decimals. 0.18x plus 0.45 times 12 is 5.4 minus 0.45x equals 4.32. Combine my like terms, 0.18x minus 0.45x. Again, I'm using my calculator with these decimals. That's minus 0.27x plus 5.4 is 4.32. Subtract the 5.4 on both sides. Minus 0.27x equals 4.32 minus 5.4 is minus 1.08. Now this time x does not have to be a nice number. In problem 1 that I did, A stood for number of adults, and we couldn't have 2.3 adults, for example. But here we could. Now, you do have to be a little bit reasonable here. X has to be somewhere between 0 and 12. So if you're doing this problem and you get x equals 15, well, you can't have 15 liters here and add more and still only end up with 12 liters. Now, I said that it doesn't have to be a nice number, but of course, most of these problems are set up so that you do get a nice number. So I divide both sides by the negative 0.27. And I do happen to get a nice number. X is 4. But on a mixture problem like this, x doesn't have to be a nice number. You could end up with a fraction or a decimal, and that would be okay. Since x is 4, y has to be 12 minus 4 is 8. Oh, so I think I said 8 and 4 at the beginning. I just had the numbers wrong. It was 4 and 8. Lucky guess. Alright, so there's a typical mixture problem. And there you go. You get to do number 4. Again, very, very similar. It just has some different numbers. But again, rewind the video if you need to. Watch what I did and fill in your numbers as you go. It should work out pretty much exactly the same.